Assalamu alaikum dear students, hope you are fine. You are utilizing this time very perfectly, and I also expect that you are watching these video lectures on regularly and taking the benefits from these video lectures. And I request you, if you have any question or any doubt or whatever, or any suggestion, whatever may be, please let me know that it will motivate me to upload more interesting video lectures. In the yesterday's video lecture, we discussed about the Thales theorem, its proof, and then later we did some short results, corollary results. Now in today's video lecture, we will discuss a little bit about the converse of Thales theorem. Its proof is not supposed to, you are not supposed to prove it here. You are just we have to demonstrate, to give the demonstration of this converse of this Thales theorem. If anybody among you is interested in the proof of this converse of Thales theorem, please let me know that I can make the video lecture for the same also. But here we just will give the bit of demonstration that what is the converse of Thales theorem. We will just state it, understand it with the help of example. That is all. We will not know, it is not required to prove here. So converse of Thales theorem is, if we have a triangle, suppose ABC, if a line DE, divides the any two sides of triangle into the same ratio, that is, if AD by DB equals AE by EC, then by the converse of Thales theorem, then DE parallel BC. What was in Thales theorem? In Thales theorem, you were given DE parallel BC, and you are required to prove that AD by DB equals AE by EC. In converse of Thales theorem, what you are given? You are given AD by DB equals AE by EC. This is given. Now you have to prove that, you have to show that, or which we have to mean that here, that DE is parallel to BC, third side. So converse of Thales theorem is that if a line divides the any two sides of a triangle into the same ratio, or divide it, we can say proportionally, then the line must be parallel to third side. This is the converse of Thales theorem. I hope you will understand it. And with the help of this converse of Thales theorem, we have exercise 6.2, question number 1, question number 2. I hope you can do it with the help of this. You have to see that whether the line is parallel to or not. If you have to see this line is parallel to not, take the ratio from here, this ratio should be equal, so you are through. So I hope you will do these two questions of your own, and if you find any difficulty or are unable to do these questions, please let me know that. These are very simple. These are left as home assignment for you. I hope you will do it. Now in today's video lecture, we will do question number 3. It's a very important question, so I will read the question. I also recommend you that while watching the video, keep the book with you. So I will read the question. In fig 6, LM parallel CB, LN parallel CD, prove that AM by MB equals AN by ND. We have given the figure. This is figure like this. It is like this, and this is figure AB. This is A, B, this is C, this is D. So what we are provided that LM is parallel to CB. This is your LM is parallel to CB, and LN is parallel to CD. Sorry, this is LN is parallel to CD. What we are required to prove AM divided by AB equals AN divided by AD. Have a look. This is very simple. We'll use the Thales theorem to prove it. We have to prove that AM by AB equals AN by AD. Very simple. If you look clearly towards the required result which we are supposed to prove, you see AM by AB. Let us look the example here. AM by AB. AM by AB. That means part of a side, and here, and it is divided by whole of side. The ratios between part and whole. So we can clearly. So sometimes you have to look towards the question, towards the result which you are supposed to prove. It will ease your procedure to prove the result. Look, AM by AB. AM by AB. Definitely we will take this ratio, and accordingly we will prove it. So we will write given is LM parallel BC, simple, and LN parallel CD. This is given. Now to prove is AM by AB equals AN by AD. Now have a look. Proof is very simple. Proof in triangle ABC. In triangle ABC, LM parallel BC, is it? LM parallel BC, is it? Of course it is. It is, as it is given. So if LM is parallel to BC, it means what? It means, can we write it? Then AM divided by AB. Have a look. Use the Thales theorem. Previous results, yesterday's results, we did corollary results. I discussed it, each and every result there. I told you that you have to take the ratio accordingly. Look, we have taken AM by AB. Why I took AM by AB? Why I have not taken AM by MB? Why? Because if you look, I already told you, sometimes you have to see the result. Then it will ease our approach to prove that required result. Have a look. It is AM by AB. Sometimes you have read that AD by DB is equal to AE by C. Why you one question might strike in your mind, that why we can't take AM by AB? We can easily take AM by MB, but we took directly AM by MB. I am talking, but here we took directly AM by AB. Why? Because this is the result which we are supposed to find. So equals, have a look. We are talking about triangle ABC. If we have taken AM by AB, so from here it will be AL by AC, half side and whole side. AL by AC. Name this first. We can. Thales theorem is not necessary that you should have triangle ABC DE. You will write AD by DB equals AE by EC, but this is the only result. It is not like that. You can use any ratio accordingly and adjust it, as we have discussed it in yesterday's video lecture. So what is the reason? By Thales theorem. But please, here I recommend you that while you are writing in your examination, write the complete theorem here. If a line is drawn parallel to any side of triangle, other two sides are divided in the same ratio. In triangle ADC, LN is parallel to CD. Why LN is parallel to CD? It is given. So again we will take the result. We will write AN by AD. AN by AD. What will be the here? It will be AL by AC. AL by AC. Name this second. Why? Because by Thales theorem. By Thales theorem. Please, while writing in the examination, don't write by Thales theorem. It might your credit, it might lower your credit. I recommend you that please, while writing in the examination, write the complete theorem here. So if you look, equation is first and second. This is AL by AC. So these are equal from first and second. from first and second we have AM by AB equals AN by AD. This was the required result which we were supposed to prove. I hope you will get it, and was very easy question. And use the result, check the result, what we are supposed to find, what we are supposed to prove. Then it will ease your procedure, it will ease your strategy, how you can go, whatever the necessary steps you have to take. So this was all about today's video lecture. I hope you will enjoy this video lecture. If you still have any question or doubt, please let me know that. Thank you, class.